everybody. Today I'm going to talk to you about nothing. Let me explain. I'm going to talk to you about atoms. I'm going to talk to you about atoms, matter, and what comprises them. I'll talk about the nothing part later. Let's start from the basics. Everything around us, including us, is made up of atoms, which by definition are the smallest particle of a chemical element that can exist. Atoms have two distinct parts. One, a nucleus, which consists of protons, which are positively charged, and neutrons, which have no charge. Isn't it weird, though, that the nucleus is held together? I mean, in school we learned that things with the same charge repel each other. All this is due to the existence of a very strange force, the strong nuclear force, which binds neutrons and protons together. Because of this force, also, the nucleus is incredibly dense. It is about 2.3 times 10 to the 17 kilograms per meters cubed. The other part of the atom is the cloud of electrons. Contrary to popular belief, electrons do not follow a predetermined path or orbit, and we can never actually know their exact position. We can only predict the likely position of the location of the electron based on a function of probabilities. Additionally, electrons have an enormous spin velocity of 2,000 kilometers per second. But for now, let's take the Bohr model into consideration, as it is easier to perceive. So let's bring an atom into our scale in order to see it from our point of view. The radii of isolated neutral atoms is about 10 to the minus 10 meters, meaning that in a human hair can fit 1,000 atoms. To make this even more extreme, the head of a pin, there are millions of atoms of steel. Also, the nucleus is 10,000 times smaller than the actual atom. But what is it between the nucleus and the outer shell of electrons? Nothing. Atoms are approximately 99.999996% empty space. So if we magnify the nucleus of an atom and brought it to the size of 1 millimeter, then the next nucleus would be about 50 meters away. So in a regular substance, for instance iron, whose density is 7.2 grams per cubed centimeters, if we were able to put one nucleus next to the other instead of it being 50 meters away, then its density would be 1 billion grams per cubed centimeter. That means that the mass of the whole human population would fit inside a single dye. This is what happens in neutron stars, which are formed when stars 4 to 8 times as massive as our Sun explode in a violent supernova. Their outer layers are blown off in an often spectacular display, leaving behind a small, dense core that continues to collapse. Gravity presses the material in on itself,